Alfa Aesar, a Johnson Matthey company, is a leading international manufacturer, supplier, and distributor of chemicals, metals, and materials. Their products are used in a variety of research, development, and production applications. The storage facility is located as part of the large warehouse complex at the intersection of Neck and Shelley Roads in the Ward Hill Industrial Park. It serves as a high-hazard storage facility for flammable liquids, flammable solids, corrosive and oxidizer classified chemicals. In all, over 5,000 different chemicals are housed in the facility. The building consists of a large warehouse structure with storage areas and offices. The Haverhill Fire Department is the primary first response emergency organization. It will respond from the Bradford Street Fire Station with a response time of 4 to 5 minutes from the time an alarm is received at the station. The facility has complete fire suppression coverage throughout all areas. Systems include an AFFF foam extinguishing system for the flammable liquids storage area and wet pipe sprinkler system protection in other areas. The building is equipped with strobe and horn strobe appliances. Beacons located outside the exterior doors to each storage area indicate which space is in alarm. An annunciator is located in the main entry lobby with the graphic directory adjacent to it. The purpose of this video is to provide the viewer with an overview of the anticipated fire hazards at the facility. It gives emergency responders a detailed look of the structure, the layout of inventory, and a description of the fire suppression systems installed. Alfa Aesar has two facilities in Haverhill, a Bond Street facility and this Shelley Road warehouse facility. Operations at the Bond Street facility are primarily repackaging of materials on site from one container to another in a dedicated repack area for certain compounds. This Shelley Road facility expands the storage space available to Alfa Aesar. It will be used for bulk storage of received material. In some limited instances, chemicals will be repackaged at this Shelley Road facility in a dedicated repack area. Chemicals will be received for storage, typically in pails, carboys, drums, and cartons. When additional quantities are required, bulk portions of material will be removed from racks and trucked to the Bond Street facility. The building has a small office area in the front. Adjacent to that is the loading dock for receiving. Product is separated in different rooms and areas for convenience, organization, and safety based on the type of material. These are broadly classified as corrosives, acids, corrosives, bases, flammable liquids, oxidizers, flammable solids, general bulk storage area. The primary method for moving product around in the facility is with manually operated or electric forklifts. Pallets are removed from trucks backed up to one of the 4 loading docks through the main corridor and into multi-level racks in the adjoining spaces. Material may also be stored in dedicated cabinets. Removal of product will follow a reverse path. Chemical storage rooms have been designed for the safe storage of specific classes of materials. Each area where chemicals will be stored or transported is separated into fire protection zones. Zone 1 is an area approximately 4,200 square feet in size, housing flammable solids. Product stored in this area is primarily metal powders and chips stored in cans, metal pails, and drums that vary in size up to 55-gallon drums. It is restricted to materials that do not react with water or have a very low reaction if in contact with water in the liquid state. Product is generally located on wooden pallets arranged in a rack system. The racks are installed to create a space between each rack and any adjacent wall of approximately 12 inches. Rack height varies based on height limitations imposed by structural and other systems, but generally is 3 or 4 levels high, including 1 level on the concrete slab. The elevation of the top level is approximately 15 feet 4 inches above the finished floor. Zone 2 is another area of similar size designed for general bulk storage in liquid or solid state. Materials stored here are anticipated to be non-reactive with each other or water in the liquid state. Again, storage is generally arranged in a rack system. Zone 4 is a 3,880 square foot area storing oxidizers. 65% of the normal inventory includes product that is, or similar in nature to, almost all of the products listed as Class 1 oxidizers. 35% of the normal inventory includes product that is, or similar in nature to, 80 to 90% of the products listed as Class 2 oxidizers. Class 3 oxidizers are not presently stored in the facility. However, should Class 3 oxidizers be placed into inventory, dedicated storage cabinets, specially constructed to house this material, are provided. These containers are designed to be connected directly to the sprinkler system so that the higher sprinkler flow densities required for Class 3 oxidizers is limited to the storage containers rather than applied to the entire space. No Class 4 oxidizers will be held in inventory at this location. Product is primarily in the solid state and is stored in cardboard boxes, bags, and other similar smaller containers, with some products stored in 5 to 10 gallon pails. Hydrogen peroxide may be stored in plastic drums, and nitric acid is stored in 20 to 30 gallon glass carboys with plastic or styrofoam overpack. Corrosives are stored in a large space on the front side of the facility. The room is divided into two sides by a floor-to-ceiling partition to separate base product from acid product. The corrosive bases are in Zone 5, and the corrosive acids are in Zone 6. Product in these areas are primarily stored in plastic pails, drums, and containers that vary in size from 1 to 2 gallon containers up to 55 gallon drums. It is generally located on wooden pallets, arranged in a rack system. As in all the previously described storage rooms, the racks are installed to create a space between each rack and any adjacent wall of approximately 12 inches. Rack height varies, but generally is 3 or 4 levels high, including level 1 on the concrete slab. The elevation of the top level is approximately 15 feet 4 inches above the finished floor. Zone 3 is the largest storage space in the warehouse. This 8,900 square foot area is where the flammable liquids are stored, including materials classified as 1B and 1C flammable liquids. Containers are primarily U.S. Department of Transportation rated and approved to contain the product. They are generally metal, although some containers are plastic. All of the containers are non-relieving style containers, consistent with the limitations and requirements. Product is located on wooden pallets arranged in a rack system. The lowest level of storage in the rack system is a fiberglass plastic-coated material that forms an open grate floor, through which any spilled liquids will fall in the event that the integrity of a container is compromised. The coated nature of the surface is intended to mitigate the formation of sparks. A concrete floor is located approximately 36 inches below the open grate floor to capture spilled liquids and any release of the AFFF extinguishing system. The racks are installed to create a space between each rack. Rack height will vary. The elevation of the top level is approximately 15 feet 4 inches above the finished open grate floor. Zone 7 is the loading dock area, where shipments of all materials will be received. This area is equipped with a portable AFFF foam cart, as well as an emergency waste room, vermiculite hood, and walk-in hood. Chemicals arriving in this area will be quickly moved to the appropriate storage area. The facility has complete fire suppression coverage throughout all areas. Systems include an AFFF foam extinguishing system for the flammable liquid storage area and wet pipe sprinkler system protection in other areas. Each hazard room is self-contained with 3 and 4 hour rated walls and doors. The heating and ventilation system is state-of-the-art, allowing up to 6 air changes per hour and reacting to self-contain any room with a problem and isolating it from the rest of the facility. The flammable liquids and solids are each in explosion-proof environments with chemical-resistant materials on the floors and walls. The flammable liquids room has a 3-foot pit under an epoxy-coated steel grid and FRP floor system. The suppression system is an AFFF foam system. UV, IR, and flame detectors act as an early warning in case of an incident. The building is completely diked, housing a possible 250,000 gallons of liquid. The fire alarm system in the building includes manual pull stations at exit discharge locations and top of stair locations, as well as any corridor areas where travel distance to an exit is 200 feet or more. Mechanical system monitoring includes duct-mounted smoke detectors to monitor supply-side ductwork of all HVAC air handlers moving more than 2,000 cubic feet per minute. In some instances, this requires 2 detectors to ensure proper distances downstream from elbows, bends, and other turbulence-causing elements of the ductwork. The duct smoke detectors are provided with remote test indicator and reset buttons. These are located in corridor areas outside the space served by the associated unit and are prominently identified. The main sprinkler system and riser valves are provided with automatic monitoring of pressure, tamper, and flow status at the zone valve assembly. The mechanical, electrical, and plumbing, or MEP systems, allow the fire department to manually control the systems from an isolated control panel. From here, one can manually release smoke hatches and mechanically ventilate a room with an incident ongoing. One can also choose to do nothing and let the building's systems control the situation. The safeguards give the fire department a window of time sufficient enough so lives are not put in harm's way if a problem arises. The basis of design for the wet pipe sprinkler system is NFPA 13, with storage areas of the facility considered as ordinary hazard Group 2 occupancy, and office areas considered as light hazard. This includes the corrosives, flammable solids, and oxidizer areas, common corridor areas, and office administrative areas. Experiences at the Alfa Aesar Bond Street facility have resulted in the requirement to be able to control or shut off the fire protection water supply to certain portions of the facility. Accordingly, in addition to the main sprinkler shutoff valve, portions of the fire protection system are arranged to isolate certain areas. All valves are supervised by the fire alarm control panel and are normally open. Tamper and flow zone isolation valves are located in or adjacent to each of the areas served by the wet pipe sprinkler system. In the specialized storage rooms, there are isolation valves for both the rack sprinklers and the overhead sprinklers. Failure of the heat sensing element at any sprinkler head will result in immediate sprinkler operation in the affected area. Water flow within an individual zone will initiate a fire alarm via the fire detection and alarm system. The main sprinkler system and riser valves are provided with automatic monitoring of pressure, tamper, and flow status at the zone valve assembly. If the tamper switch at any system component is activated, or if the low water pressure switch is activated, this signal will cause a trouble condition on the fire alarm control panel, and its identification will be enunciated. An aqueous film-forming foam, or AFFF system, provides coverage for the flammable liquid storage area. The AFFF tank and associated valves are located in a mechanical room at the exterior of the building, but central to the location of the flammable liquid storage area. This facilitates shorter foam extinguishing agent release times once a system is activated. A single cache of AFFF concentrate is stored in 2 vertical tanks, a main and reserve tank. It is used to supply AFFF concentrate to the flammable liquids storage area through a dedicated alarm. The reserve tank would be used to protect the flammable liquids room in the event that the normal operations can be restored to the space after a foam discharge. For example, the reserve tank could be used to coat the interior surfaces of the space through any open foam sprinkler heads prior to sending firefighting personnel into the space after a foam release. The water activation valve on the side of the reserve tank is normally left in the closed position. In order to place this reserve AFFF tank into service, the water activation valve must be opened manually. The AFFF system water supply for the flammable liquid storage space is arranged to allow the water supply to be shut off for the space with the use of outside stem and yoke valves that can be remotely operated from outside the building. These are located adjacent to the mechanical room on the west side of the building. Here, one will find the fire department connection for the flammable liquids room AFFF system. The valve is the fire protection water shutoff valve for the flammable liquids room only. A test pipe is located here as well for testing the foam system. The fire suppression system in the flammable liquid storage area is a pre-primed AFFF system. Flame detectors are located below the floor grid as well as above the floor. Heat from a developing fire will cause the release of the AFFF solution at the local area closest to the source of heat. UVIR detectors located throughout the space will also signal the system. These serve only as an early warning device to summon emergency response personnel to the site, based on a signal received from the fire alarm system. The control panels for the AFFF equipment are located in the mechanical room, where the AFFF tanks and valves are located. This permits access for maintenance and operation of the panel without entering the spaces served. This is designed to minimize risk to responding emergency personnel if the system must be accessed for information or reset during an emergency. A portable AFFF system is located in the loading dock area. Each portion of the warehouse space is provided with a dedicated air handling rooftop or energy recovery unit. The flammable liquid storage area is equipped with an energy recovery unit that does not recirculate air, but provides 100% outside air when in operation. Air is withdrawn from the space served by the same unit and exhausted through a heat recovery wheel at a rate of 4 air changes per hour. Air is completely replaced in the affected space every 15 minutes. Other warehouse spaces and the main corridor connecting them are served with separate air handling units that typically recirculate approximately 95% of the air. They have the capability to operate with an economizer to completely replace the air in each space with outside air. These units recirculate or replace the air in the spaces served at a rate of 6 air changes per hour. Air is completely replaced every 10 minutes. All air handling equipment will automatically be de-energized in the event of a fire. Smoke hatch openings are available for evacuation of smoke and fumes from storage rooms 117, 118, and 120. The activation of these spring-activated hatches is accomplished manually from a separate set of controls next to the fire alarm control panel. Manually operated smoke removal fans are located in each of the storage areas. Controls for these hatches are located in the foyer next to the fire alarm panel. The basis for design for the fire alarm system includes compliance with NFPA and the Massachusetts building codes. The system provides manual and automatic operation with on-site audio and visual alarms to indicate a fire event within the building. The fire alarm system includes manual pull stations at exit discharge locations and top-of-stair locations, as well as any corridor areas where travel distance to an exit is 200 feet or more. Mechanical system monitoring includes duct-mounted smoke detectors to monitor supply-side ductwork of all HVAC handlers moving more than 2,000 cubic feet per minute. The duct smoke detectors are provided with remote test indicator and reset buttons. These are located in corridor areas outside the space served by the associated unit and prominently identified. The main sprinkler system and riser valves are provided with automatic monitoring of pressure, tamper, and flow status at the zone valve assembly. The building fire alarm zoning is geographic in nature and essentially follows the building areas defined by this drawing, shown graphically on a Lexan fire alarm directory located at the main entry. The system includes a remote annunciator with test, system silence, and system reset switches behind a locked cover. The annunciator is located in the main entry lobby with the graphic directory located adjacent to it. The building is equipped with strobe and horn appliances. Beacons are located outside of exterior and interior doors to each storage area in order to indicate which space is in alarm. 2 beacons are mounted on the front corner of the building where first responders can easily see them on approach to the scene. A red beacon indicates the building is in alarm. An amber beacon indicates the alarm is in the flammable liquids area and that the AFFF foam system has been deployed. The actual sequence of events in an alarm condition depends on where the event takes place. If the alarm condition is in the flammable liquid storage area, it will activate the AFFF system. The likely sequence of events would be as follows. Failure of the heat sensing element will result in immediate system operation in the affected area. The AFFF system will activate, resulting in the discharge of AFFF solution through all of the open heads in the flammable liquids storage room. Heat sensors or flame detectors in the immediate area of the open head will activate the alarm system. The associated zone shall be enunciated on the fire alarm control panel. Horn and strobe devices shall operate throughout the facility. HVAC unit serving the flammable liquid storage room shall be de-energized, and fire and smoke dampers shall close. The magnetic door holder and other similar devices shall operate, resulting in door closure of forklift and personnel doors. The fire alarm sequence will be initiated. Ceiling or duct-mounted smoke detectors will provide a signal, along with the address of the associated